Yes, sir. I made you as presenter, sir.
Yeah, now I am able to share.
Yes, sir. We welcome you, sir, to the 12th session of Atal FDP program, sir.
Yeah.
So kindly take your session, sir.
Yeah, I'll do that. All right. Can you see the screen, please?
Yes, sir. It is artificial intelligence, past, present, and future of AI things.
Yeah. All right. So, first of all, I thank Professor Samshurao Garu, whom I met a few years ago, and I visited NRI Institute of Technology for a couple of times in the past. And Professor Samshurao definitely takes proactive role in organizing such nice FDPs which are of utility for everybody. Generally, research areas come and go, but some research areas, they are going to have lasting impact on humanity. You can say AI revolution is possibly the fourth industrial revolution. So generally, when you attend a lecture of this nature, sometimes there are hands-on sessions where people are really conversant with the current AI tools and data science tools, machine learning tools like deep learning, Keras, and TensorFlow, how to use them, PyTorch. So you kind of get to know the tools. But sometimes there are lectures of the type that I am giving yesterday and today. They are generally meant to see what will happen in the future. Generally, you don't find this information anywhere. Purposefully, the title, like we got to be honest, that somewhere in 1950s or late 1940s, Makula and Pitts were trying to understand the model of neuron. And they came up with the first model of neuron. And the area of artificial neural networks kind of took a lot of importance. But maybe 15 years later, pattern recognition took, I will come to that in a little while. The main point I wanted to make was there was a professor at Stanford who was interested in making a machine recognize human voice. So the area of speech recognition initially looks like a science fiction idea, but somebody sees that it is doable, like with many inventions. Okay, whether it is space technology, whether it is radio, whether it is television, whether it is telephone, and whether it is cell phone, somebody kind of sees the potential and tries to work. And there again, the quotation of Thomas Alva Edison takes a very important role. Edison once said, genius is 10% inspiration and 90% perspiration. So when he wanted to invent electric bulb, he kind of experimented with about 50 materials. Finally, he took tungsten. Like many of his inventions, a lot of effort went in, but finally he succeeded and he started GE, General Electric. Of course, Tesla proposed alternating AC, And AC, for many reasons, kind of took front seat compared to DC. So when McCarthy proposed at a conference the words artificial intelligence, it was kind of beginning of AI. Look, we got to give due credit to McCarthy for having started the area or for having made initial efforts. And his students, some of them are of Indian origin, they really took the technology into the current shape. And currently, you know that Alexa, Siri, Alexa, can you switch on the lights? Alexa, do something. So the speech recognition technology by, let's say, Amazon is taking active role in enabling a human being to communicate with a machine, right? And yesterday there was some introduction about Darwin, but today I will skip that. So normally coining words is kind of good, but I can say biological intelligence, BI. I can say CI, computational intelligence. I can say DI, distributed intelligence. I can say FI, federated intelligence. So there is nothing so big in words, but they kind of get you started. And generally, we need the activity to start. See, Professor Shamshirao took the active role to kind of get the community, maybe not only from Andhra Pradesh, but other parts of Telangana, all over India, to kind of enjoy few days of intense sessions, which included some hands-on sessions. And is Kanishk there? Are there anybody from Mahindra University? Because I wanted some of them to join if they are interested. So normally, whenever you want to do something new, you have to understand that people, just like in any research work, you got to know what the other people have done. And generally, I tell my students three things. That is, if you don't cheat yourself, that is, you don't read some web page, you don't read some book, or you don't attend a FDP like this and you claim the idea is yours. That is cheating oneself. If you don't cheat yourself, suppose you don't read literature, you come up with an idea, and the idea is already there, but you have satisfaction, but you don't get any credit. Sometimes you come up with an idea, part of it is new, part of it is known. So you get some credit and you get full satisfaction. Sometimes it also happens, many times very senior researchers, they don't read literature. They come up with an idea. There is nothing like that in literature. That can happen from India. That can happen from NRI Institute. That is, whether you are in MIT, whether you are in Stanford, whether you are in Oxford, whether you are in Cambridge, whether you are in Göttingen, whether you are in Riken, whether you are in, let's say, Nanyang Technological University. If the idea is good, people are willing to take it. So, in realizing AI, there are lots of ideas, and generally any research area, first, you understand what was the vision. Second, you kind of understand what people tried what were the roadblocks? That is, they were unable to cross some barriers. Slowly, suddenly a new idea comes and you cross over the barrier. Okay, like search engine but the two guys were their names, Larry Page and Sergey Brin. They tried out, and maybe Zuckerberg tried Facebook. So all these companies are investing heavily on AI, and governments all over the world are investing heavily on AI. So AI past, present, and future, and AI of things, artificial intelligence of things, right? So let's get started. We go to the second slide. So we'll give you an overview of AI. First of all, what is AI? First of all, you ask a question, what is intelligence? Okay. Now, when you want to give a definition, the kind of definition varies from person to person. And a mathematician like David Hilbert once said, a good definition is 50% of the research problem solution. He was referring to the concept of countable set by George Cantor. So the idea of countable sets had lots of implications to set theory. So in some sense, it is hard to pin down the notion of intelligence. Somebody very intelligent in India could be somebody who goes to an IIT. But does that mean that somebody who went to MSc mathematics, MSc physics is kind of stupid? No. Some of them go on to win some very prestigious awards all over the world. So do you mean to say intelligence is a constant thing? Not really. So we'll get into the beginnings of AI and early efforts. Yesterday in my talk, I mentioned a sequence of numbers. The simplest sequence could be 2, 4, 6, 8, and so on. So the sequence of even numbers are 2, 3, 5, 7, 11, 13, 17, 19. What are these? Anybody in the audience? What are these? 2, 3, 5, 7, 11, 13. What are these? Prime numbers. And an Indian professor became very famous because he came up with an algorithm along with his two students, a polynomial time algorithm for determining whether a given number is prime. Okay? All right. Now, so generally in India and many other countries, when you want to go to very selected schools, there are limited number of seats. The whole country is competing. So we got to have something like JEE, JEE Advanced. So one of the professors said, you cracked the JEE, Advanced JEE, one of the toughest exams in the whole world. All right? Now, generally intelligence tests sometimes deal with numerical patterns, sometimes they deal with pictorial patterns, sometimes they deal with sound-based patterns or video-based patterns. I'm sure you see some of these CAPTCHA kind of trying to test your identity. So now let's come to the beginnings of AI and then some simple AI tasks, particularly special applications where AI proved to be valuable. And one of the goals of AI to be able to mimic human-like abilities in some areas. Some of the recent developments in AI and ML, future hopes for AI, and ethical aspects of AI. The ultimate AI, that is, you want a machine just like you, all right? Okay. Now, what is machine learning? Because AI has a lot to do with machine learning. First of all, what is learning? If you cannot understand what is learning, we may emulate learning in machines. We want to understand learning mechanisms in animals and humans. Sometimes one of the most intricate machines in the universe is the human brain. All right. Now, there are neuroscientists trying to understand the human brain. Okay. If you are really into biological AI, really try to understand neuroscience. Just like the map of the world, the map of the universe. We have planets, we have our planet, sun, and we have our Milky Way galaxy. We have Sagittarius, we have Andromeda galaxy, we have quasars, we have pulsars, and so on. So we map the living universe to some extent. We mapped the non-living universe. When we come to human brain, we want to know what parts of the brain are responsible for vision. Now, when you want to know, look, this is relevant for the theme that I am given to give lecture on. Please be patient. Now, we want to know what parts of the human brain are responsible for vision, speech, motor areas, and so on and so forth. So, there is something called visual cortex. The left side of your brain to the rear is the visual cortex. Two scientists by name Howell and Wiesel, I believe they were from Harvard, they kind of took a cat and they were possibly the first ones. I'm not 100% sure if electroencephalogram was already there. ECG possibly was there to measure the electrical activity of the human heart, ECG. So a healthy human being, what's the pattern? What is abnormal? So let's take an AI application. Like you give an ECG signal, the doctor doesn't have to analyze it. The machine takes your ECG, analyzes it, tells you, look, you are normal, if you are abnormal, what's the problem? Is the problem with the valves? Is the problem with something to do with the membrane of the human heart? And so on and so forth. Those are heart diseases. So we are not deviating. We want to know the visual cortex. So Howell and Wiesel put electrodes on the human visual cortex, particularly they took cat. Faithful to Darwin, we are evolved animals. Now, so what Howell and Wiesel did was they projected light into the left eye of the cat and they inferred that there are orientation selective cells in the visual cortex. And they received a Nobel Prize for, I believe maybe medicine, I think, somewhere, some discipline. They received a Nobel Prize. So Howell and Wiesel kind of started a flurry of activity about learning the human brain. Now, in India, if you are a student, you want to know brain science, there is an institute in Manesar, Haryana called National Brain Research Center. Possibly send a letter, I want to do internship, possibly you get it. They do both computational intelligence, they also do biological intelligence. Also, in Tokyo, there is RIKEN, in the institute called RIKEN, lot of brain science research. In United States, it is Salk Institute in San Diego. In UK, it is Gatsby Institute. In Germany, Max Planck Institute. And Italy, France, Spain, I am sure Spain has. And in fact, Cuba has. About 20 years, maybe not 20, 15 years ago, a professor by name Pedro sent me a mail and he said, we read your book and can you share with us? It's a very good book on neural networks. Can you share some software? Unfortunately, I didn't write any software because I have limited time and I have to do some things that I enjoy. And when I was at your age, I used to write programs in Fortran. I used to write programs in assembly language and so on. But maybe if I sit down, I can write code. All right, coming back. So we mapped the human brain into visual cortex, motor areas, parietal lobe, and other thalamus, and I forget the other names. So the brain is mapped. Now, the ultimate goal of AI, you see, I kind of use the word computational AI versus biological AI. See, the advancements in neuroscience definitely have a bearing on computational AI. We are trying to emulate the learning by machines, all right? Yeah. So let's start with human being. That is, you are born as a child, and your mother, your father, they take care of you. So how does a child learn language? All right? Now the first things a child does, he learns to recognize mother and father. So Huffield asked the question, how does the child recognize the mother and father? Is it like computer memory or something different? So Huffield created a computational model of associative memory. You associate the face of your mother with something stored in your brain. Believe me, we have a computational model. My gut feeling, that's not what the human brain does. I'm sure that's not what the human brain does. All right. Generally, you got to understand, nature does something. Typically, human beings were trying to emulate what nature does, like optimization heuristics, like ACO, PSO, and so on. But they are very, very helpful to solve even NP hard problems, very difficult problems. But you must understand, we may be glorifying nature. Maybe there are machines which can do many things very differently. So we learn pattern recognition. We learn image processing, how a child learns language, how a child learns patterns, how a child learns to play games, how a child recognizes mother and father. So the research efforts are to answer such questions. So cognitive mechanisms are not fully understood, particularly how the brain works. All right. Now, sometimes people are trying. We got to try. We got to invest in some disciplines. And if you invest in 10, if one of them flies, it pays for all the 10. All right. So, just like any investment principle. So, we want to know, starting with a child, gradually learning the language. Can a robot learn the language? My feeling, yes. All right. You must understand, just like your LLM models, large language models, possibly something similar is done in the human brain. Well, I am not 100% sure. How the child learns to play games, how Gukesh became a chess champion, youngest grandmaster. So generally Russians used to be very good at chess playing games. All right, I'll come to that in a minute. So we want to spend some time on the learning paradigms. We want to have some computational abstraction of learning in living systems. So you take a slate, you write down the alphabets, A, E, and so on. You tell your child to diddu, so the child repeats, and he recognizes alphabet symbols well. After a while, you kind of test the child. If he hasn't learned the alphabet correctly, you ask him to learn again. So there is training data. For each training pattern, you have a class label. You have a class label. And the child recognizes the class label given a pattern. So in supervised learning by a teacher, the teacher knows the class label for every pattern. And sometimes you may feel that's all there is to it. That is, everything is supervised learning, but really not. Then I forget the fellow who came up with K-means algorithm. The idea of K-means, kind of pretty simple idea, but people are still using it, or variations of it. So the patterns are clustered in the Euclidean space or some other metric, and you take a new pattern, check the distance, and put it in one of the clusters. So after the clustering is done, you have learned the patterns and their class labels. Okay, now that is unsupervised learning. All right, maybe there are some other variations of unsupervised learning. Like if you want to do research in clustering, incremental clustering is still, kind of an area which is currently being attempted. So if you are looking for research directions, Please pay a little bit of attention. Semi-supervised learning. Part of the data, typically small amount of data, has class labels, but there is a large amount of data which doesn't have class labels. So that is semi-supervised learning. Then we have contrastive learning. You want to distinguish between two objects. So you show both of them, and the child or the machine does some kind of contrast between the two and learns to recognize both the patterns or both the objects, whatever you like. There is also what's called incremental learning. What is incremental learning? Basically, you trained an ANN to learn, let's say, 4 animals: tigers, cats, dogs, cows. Suddenly we get buffaloes, you get deers, you get elephants. So do you retrain the whole network? That's kind of brute force idea. People realized that you can train a network by just incrementally changing the weights, changing the architecture, and trying out. And there are some promising approaches, including by me and my students. So if you are looking for a research direction, particularly AI involves machine learning, which involves neural networks. All right. So these words, you just decision trees, neural networks, logic, and others come under machine learning. AI is a part of, or machine learning is a part of AI. So incremental learning is an interesting research direction. And these days, you possibly know transfer learning. You learned a model, you have a new application which is related. Can you transfer the learning that you have learned, that you have trained a network for solving a more general problem? Transfer learning. And I don't know whether it is IIT Hyderabad. There is a lady who came up with self-supervised learning. That is, there is no external supervisor. You are doing self-supervision. All right. Now, I'll always remember one thing. Generally, a curious idea can come from a faculty in Mahindra University. An idea a professor floated, and somebody from an IIT heard it, and he made it big. Follow me. Or somebody from some other university in the world heard it, and he made it big. Generally, ethical people, they give credit to the original author, because that's how whole science, technology, whole human efforts are evolved. You always give credit to an earlier author to the extent he deserves. He could be a Chinese. You got to tell what the Chinese professor did and what is it that you did newly. And the Chinese professor, if he reads, he tells, yep, this is a new idea. This is a new idea. All right. Now, some novel, all right. I didn't tell one thing. Reinforcement learning. You make an investment, you really have lots of nice ideas. That is, there is an actor, there is a critic. An actor takes an action, The critic either rewards or punishes. There is no corpus of data. It is online learning. Online learning. Like in ChatGPT and many other things that I discussed yesterday in generative AI. Kind of bread and butter for generative AI. Sometimes one of the research directions I can tell you is a hybrid of reinforcement learning and ABCD above. It's a kind of hybrid. It's not fully reinforcement learning. It's not fully supervised learning. Some kind of hybrid. And there is an area called probably approximately correct learning or PAC learning. Like the word probably, the learning is very probabilistic. A professor from Harvard wrote a book on this area. All right. So we discussed learning paradigms. Are there any questions at this stage? You can unmute and ask because I'm going to jump into something new. Okay. I'll give you a minute. If you have a question, you can ask. You may end up coming up with some other learning paradigms or some recent phrases for learning, like shallow learning versus deep learning. So most of you know that when you have MLP, when you have CNN, the architecture, the number of layers, the number of hidden layers in MLP was kind of try it out, trial and error. About 2010, there was an area called generative neural networks. And there are lots of nice ideas on how to decide the architecture. People in a multi-layer perceptron, they kind of increased the number of hidden layers and they were getting good accuracy. So Jan LeCun came up with the idea of convolutional neural networks. Of course, Fukushima in Japan wrote a paper 30 years before him called Neocognitron. I'm sure there is some American author, forget it is Rumelhart or some other person, called Cognitron. So people try, something succeeds, every one of us will get the benefits. So shallow learning is number of hidden layers is small, deep learning number of convolutional layers and pooling layers, number of hidden layers is large, more than maybe 5 or 10 some number. Then there is an area called active learning. You are not passively learning, but you are actively learning. And I discussed the other ones. Now, when you come to research work, some work is very applied. That is, your hands-on sessions. I think Professor Shamshirao wanted a title for the FDP, which has a lot to do with applications, or the research efforts, how they help in AI applications. So, which is good. Sometimes people are interested in questions like, can you tell me why a CNN works? See, MLP, you have gradient descent. You can explain by gradient descent. Of course, a theoretical understanding tells you how you can improve, what are the limitations, why sometimes you get wrong answers. All right. So, for instance, you say like you get stuck in local minima because the gradient is 0 at local minima as well as global minima. So people came up with some solutions. Now, suppose you take a CNN, you take the input, and just change let's say a few pixels. I think one of the Chinese professors, I think he gave an example. I don't remember exactly. A panda was classified as lion. He took the image of a panda, he made few changes to the pixels, and it is getting classified as a horse. So this is called adversarial machine learning. An adversary can change your data a little bit, and he can cause a large mistake in the class label. So adversarial machine learning is still active. Generally, you want to ask a question like, what is learnable? Okay, and because I don't have a writing pad with me, but I'll quickly tell you. There is a paper in IEEE Spectrum, I believe, by Ian Goodfellow. So what this fellow says is, in any supervised learning, you give the training data and you have a decision boundary between two classes. Let's say two classes, real simple. So you have the decision boundary. But maybe you don't know the true decision boundary. You are given limited data. Based upon the data, you have learned a decision boundary. But the true decision boundary, you don't know. So if the patterns lie in the interstices between learned decision boundary and the true decision boundary, you get a wrong classification. So to me, the idea is a fundamental limitation of supervised learning. It is a fundamental limitation. A professor at Harvard wrote a paper, A Theory of Learnable. He's good at probability and statistics. A theory of learnable. That is, what are the basic limitations of learning systems? Can those limits be reached? Can those limits tell you, look, this is the best you can do? Okay. So, I think I made the point. You want to do theoretical research. You want to do applied research. Now, I spend a little time on the AI of things, predictive analytics. So this notion of AI of things comes from Internet of Things. I'm sure all of you know that we used to have IPv4 addresses, which are 32 bits or 4 bytes. Just to give you an indication, the MAC address of an Ethernet card is about 8 bytes or 48 bits. When Larry Page and Sergey Brin, they wanted to come up with Google, they want all the data on World Wide Web to be searchable, to be reachable. So they had this idea that all the data on the World Wide Web is about 2 power 72 bits. I think in the literature it is called Google. So they named the company Google. Now, people realize that internet is really doing wonders. So can we connect everything in the world? Your trains, your aircrafts, your geysers, your refrigerators, whatever in the home, everywhere. Can we connect them to the internet? So that is the vision of Internet of Things. And IPv6 addresses are 128 bits. 128 bits are 16 bytes. So 2 power 128 minus 1, possibly the number of atoms in the universe is much smaller than the number that you have. I'm not sure, but I can say Eddington was very favorite of this kind of calculations. Sir Arthur Eddington. So AI of things, predictive analytics. You want to predict that your geyser is going to run out of water, or the milk in refrigerator is going to get exhausted. Prediction, there are two words, predictive analytics. Prediction is the ability to forecast the outcome. You want to forecast the trajectory of a launch vehicle. Analytics, you analyze the information coming from a phenomenon. The data could be one-dimensional, two-dimensional, or three-dimensional. Text, speech, images, video. So we want to enable a machine to perform predictive analytics. See a couple of, I told you yesterday's lecture, that Telangana government sponsored a talk at a very expensive hotel, AI in healthcare, AI in business, AI in, look, I don't know whether some of you attended yesterday's talk. I listed about 15 areas. If I have time at the end, I'll kind of flash that slide. There are 15 or 20 areas where AI is going to have significant impact, enabling a machine to perform predictive analytics. Big data, another area. So I was at a interview for faculty position. Somebody said, my area is big data. So one of the interviewers asked, what is big data? Can you give definition of big data? So the person was saying, look, the data that doesn't fit in the RAM of a machine. That's not quite true. Kind of volume, velocity, variety, 3 V's to 4 V's. I was at a conference in Goa. There were about 9 V's for big data definition. One of them was viscosity of data. So there is an explosion of data. Okay? So your algorithms, your AI algorithms, can remember, AI algorithms, if they only work for small data, you are in trouble. Typically, in many applications, the data that you get is big data. Okay? Yeah. All right. What is artificial intelligence of things? I already discussed Internet of Things, endowing things with intelligence. That is, the things, the so-called things that you deal with in IoT, they are endowed with intelligence. So what's the first step? You want to give weak artificial intelligence. Again, when you talk of weak AI associated with things like, see, look, we want civilized behavior. That is, you give an entrance exam, you go through curriculum. Not everybody gets in to, let's say, engineering, JEE, or an IIT. But you get into some institute, and nothing prevents you from getting a Turing Award from a small university, because it is the work that you do, not the institute. Okay. In our language, there is a quotation. I'll translate it into English. Tell the name of the tree and sell the fruits. So if your fruits are really good, then they are good. Right. So, but generally, sometimes human beings have varied intelligence. Office assistant. So you go to any university or any organization, there is a secretary. So the secretary keeps track of itinerary of the VC, or she keeps track of what are the engagements. So people thought over this, said, can we have office assistant? Look, I don't keep track of whether it is Google or it is Amazon or it is Microsoft. They have this office assistant. So some things which can be automated. Here, when you talk of IoT, we have a bunch of sensors. So typically, the sensors based things, they do sensing, they do local computation, they do local communication seamlessly. Okay. Now, for instance, sometimes these things could be capable of autonomous decision making to enable a cyber physical system. I hope some of you or most of you know cyber physical system. I'm sure you know a network of wireless sensors or network of wired sensors. There is a feedback loop. That is, suppose the geyser is run out of water, suppose, then you automatically turn the valve. So you sense, you do some computation, and you do some control. About 1994, I released my theory. The theory of computation, communication, and control. There is a book that I have written called Multidimensional Neural Networks, Unified Theory. It's available from New Age publishers. It's about 500 rupees. Maybe some of you can purchase the book. I'm sure Professor Shamshi Rao knows about the book. Now, they asked me for a second edition. See what this unified theory is. Any biological organism, even including machines, living machines like human beings, they are capable of three things: computation, communication, and control. So Norbert Wiener coined the word cybernetics. He coined the word cybernetics. My book, My Unified Theory, provides a kind of mathematical basis for unifying computation, communication, and control. All right? So you can read more about it in the book. Strong AI of things. That is, we are not doing weak AI. Look, the words like weak AI, strong AI, they cannot tell you that the intelligence is routine, but the intelligence sometimes requires cognitive abilities in machines, machines with cognitive abilities, strong AI. The ultimate goal is thinking machines capable of all tasks a human being can do without human weaknesses and limitations. You see, in many countries, autonomous driving vehicles are a reality. You go to UK, you go to Japan, you use your cell phone, you book a cab, it comes, stops, picks you up, takes you to the destination. Now, you may, 15 years, you may thought, this is strong AI. Look, at this point in time, it's very relevant. I want to say that if you kind of go back to 1900s, Rutherford made an experiment. He took alpha radiation and he bombarded a gold foil, and he predicted that there is a nucleus and there is the atomic model in physics. Then J.J. Thomson kind of invented electron. So Thomson was very famous, very reputed. But Thomson made a statement, nothing heavier than bird can fly in the space. He is totally wrong. That is, we now have even the drones, even a child can play with a drone and control its trajectory. So, a Nobel Prize winner, Roger Penrose, said in his book, Shadows of Mind, you can never have a machine which can do all the things that human being can do. My feeling, 20, 30 years, there will be robots which can do all the things you can do, if not more. Towards the end, I'll tell you what the problems are. Artificial intelligence of things, edge computing. I am sure all of you know cloud computing. An Indian professor in Australia gave the vision of grid computing. You want the computing to be given as a utility, like water, electricity. So you want to organize a large conference, you pay for the data center, you pay. So you wanted it to be utility. From grid computing came cloud computing. So there is a data center in Bangalore, and you want the information to be processed. But it so turns out that if a hospital has medical records of a patient and it wants to know what is the likelihood that you'll have heart attack, by the time you send the data and maybe to Bangalore and you get the results, maybe the patient is dead. Maybe the patient is dead. So people said, they came up with the idea of fog computing. Fog computing. Then came mist computing. That is, use the local resources. You decrease the geographical region. Fog, mist, dew, and I coined the word bubble computing. I coined the word bubble computing. That is, you do the computing on your cell phone. And I'll tell you the vision of it sometime later. I presented the research paper at NRI Institute, and they gave me a best paper award for bubble computing. So we want to endow things with at least weak intelligence. Like you may see on television, in Japan, you take intelligent chairs. That is, when a bunch of people walk into a room, chairs automatically come to the table and assemble. All right? So you may see this on television. Intelligent lighting systems like Philips. You want to go into a conference room, the room is dark, automatically the lights flash, and they kind of monitor the groups very well. So these are called smart spaces. Think Bill Gates' house has these smart spaces. So generally, your imagination is the limit to endow things with intelligence. If you are taking one message from this talk, your imagination is the limit to endow things with intelligence. Weak intelligence, strong intelligence, cognitive abilities, it's going to happen. That is future of AI. And in a while I'll tell you it is very scary. Automatic operation of floodgates in the event of floods. There's a lot of research activity on cyber physical systems. IISc Bangalore has a center, I forget, recollect, Robert Bosch Center for Cyber Physical Systems. I think Gopalakrishnan of Infosys, believe he donated about 500 crores for IISc Bangalore for a neurocomputing. Bubble computing based on smart handheld devices. Bubble computing. So AI-enabled wearable gadgets for health monitoring in hospitals. They're already there in Singapore. I'm sure they are going to be there in India. Hospitals will have health jackets. So the simple principle that I can tell to enable intelligence to things, think of all the ways human intervention can be replaced by onboard intelligence in things. So you may, like you want to give a popular talk, intelligence means autonomy. Autonomy. So control of intelligent things requires activators. So intelligent things, if you attended yesterday's talk, I talked about generative AI, text-based, image, video, and whatever you can think of. Intelligent things enabled with generative AI. That's a kind of a vision. So now we come to future of AI of things. We want to endow things with perception. See, this word, it's not a buzzword. Please remember, when you are driving a car, You have your eyes, you have your ears, you have your legs, and so on. We want to replace a human being with a driver. Some time ago, I did a research paper on emotion recognition based on CNNs. See, we can have hybrid vehicles. That is not full autonomy, but partial autonomy. Suppose you are driving on highways. You can turn it into automatic mode, like in autopilot in aircrafts or auto train, the train which drives itself. Train which drives itself. I believe this, what's this called? Some express train, I forget the name, any rate. So, this notion of perception is very real. See, all these advancements in AI, I think I'll come to that in a little while. Perception, you have to be able to perceive the environment around you. So you take a vehicle, put sensors all over the place, cameras, radar, lidar, whatever, accelerometer, whatever. So you want machine to drive itself. The machine minimally has to have perception. And you may want to give cognitive abilities to machines or to things. Things that enable human life more comfortable. Robots to help elderly. I think Sony from Japan already sells these robots to help elderly people and disabled people. So what's the approach to realize AI of things? First principle, exhaustive identification of intelligent tasks. Take an application in any domain, business, education, entertainment, marketing, whatever. Exhaustively identify the intelligent tasks, weak as well as strong. Like a machine to suggest you to invest in stock market. So based upon a lot of data, it tells you, look, you invest in this stock. It's not weak, it is kind of currently strong. Current AI approaches to realize those tasks. What are the current techniques available? Identification of absolutely necessary and useful tasks that things can be endowed with. That is, to call a thing to be AI enabled. I'm sure there are going to be some standards. I don't know whether in the world, how many of you heard of IETF? Internet Engineering Task Force. It sets the standards for IoT things or many things. So identification of absolutely necessary and useful tasks, I'm sure people are already telling that you better be careful with strong AI for robots. There are going to be standards. There are going to be requirements for AI-enabled things. I'm sure there will be standards, ideas, tools, formalism required to realize things capable of strong AI. There are already things like expert systems. There are already reasoning systems. So we want detailed theories, we want working systems and their deployment for AI of things. Okay? And yesterday I spent some time on this and kind of I skip it. So McCarthy from Stanford coined the word AI. And chess, yesterday I talked about. And I'll call you back in 30 minutes. I'll call you back in 30 minutes. So there are, can a grandmaster like Gukesh lose to an AI machine playing chess? Maybe yes. So generally, these expert systems are built on rule-based ideas, based upon a bunch of rules, like in MySyn, medical expert system.
Hello, sir.
Yeah.
Sir, sorry, sir. Sir, a small request.
Yeah.
So, can you conclude in another 5 minutes? Because the participants have to go to Atal FDP portal and attempt their online test.
Okay. So quickly, ANNs.
Yeah.
All right. I already went over it. Yeah. All right. So higher mental abilities like logical reasoning, and ANNs, fuzzy logic, genetic algorithms, evolutionary computation, formalization, mechanization of logic, theorem proving systems. And as I already told, adversarial machine learning, generative adversarial networks are kind of things. Now, I'll spend a little time because having attended my lecture, be clear, lot of people all over the world are cautioning, you better be careful in endowing strong AI to robots, ability to replicate mental abilities like proving theorems in geometry, discovering hidden patterns in databases, surpass human abilities in some application areas, overcome human weaknesses and limitations. Machine learning in science and technology. And I propose self-evolving optimizing systems like Darwin's ideas for robots, first generation robots, second generation robots, third generation robots, and so on. Learning from mistakes. All right. Best of both worlds. Human abilities, machine abilities. Automation of capabilities of human beings. Ethical aspects of, this is the book written by a fellow called Ray Kurzweil. Humanoid robots empowered with the abilities that enable them to work against human beings. If you are careless, this will happen. Controlling humanoid robots by remote control, culture of robots, and adversarial plots, warfare based on robots, thinking robots capable of not only human abilities, but unmanned aerial vehicles. So quickly, I flash these slides. We don't have time. All right, I think I conclude now. Dr. Samshivram.
Yes, sir. Yes, sir. Sir, kindly conclude, sir.
Okay, look, lots of information was given to you. Past of AI, present of AI, and future of AI. Look, we are glorifying human beings. I am 100% sure of it. If you are careless, a technology brings with it good and bad. Computer networks, viruses, cyber warfare, cyber crimes. So any technology brings with it good and some bad. Good, we want to capitalize, but the bad, we want to kind of try to control it. So there will be AI rules to build AI systems, and there will be rules to enforce AI utilization across the world. So I hope you learned something new. I wanted to use another PPT, both the talks, generative AI from yesterday and AI systems enabled with generative AI can do a lot of good and maybe some bad. So I hope you learned something new. Yeah.
Yes, sir. Sir, thank you very much, sir. On behalf of the organizing committee of Atal FDP program, I extend our sincere gratitude to Professor Rama Murthy for delivering a thought-provoking lecture on the future of AI. Your insights into the opportunities and challenges of AI have been truly inspiring and have broadened our perspective on this transformative field. Thank you, sir, Professor Rama Murthy, for sharing your expertise with us today.
Thank you, Professor Samshivarav. All the best.
Yeah, sir. Yeah. Thank you, sir. Thank you very much.
Thank you. Good luck. Yeah.
Thank you, sir. Thank you. Thank you very much, sir. Hello, dear participants. Hello, can you hear me?
Good evening. Yes, sir. Good evening, sir.
Yes, sir.
Yes, sir. Good evening, sir.
Good evening. Sir, can you see my screen, sir?
Yes, sir.
Sir, this is
Yes.
Atal FDP portal, sir. I think you must have logged into this portal and registered for my program. So
Yes,
on
sir.
the left side, left pane, so you have one option called assessment. Kindly check it, sir.
Yes, sir.
So assessment. So in my portal, it is showing as test marks, but in your case, it is assessment.
Yes, sir.
So kindly attempt your online test from 6:30 p.m., sir.
Okay, sir.
And also there is a feedback. So there is option called feedback in your portal. Kindly check.
Yes, sir.
So please also give your feedback. Unless you complete feedback and test both, you will not get the certificate, sir. So those who fulfill the attendance norms, attendance I will post from my side, but test marks and your feedbacks, so you have to give from your side. So I will update attendance by another 2 or 3 days. And then only you can download your certificate, participation certificate. Sir, is it clear?
Okay, sir.
Yes,
Yeah.
sir.
Yeah. So kindly
Excuse me, sir.
attempt your test. Yeah, sir. Yes, sir.
Sir, assessment link is not visible in my login, sir.
Sir, you can see assessment.
Yeah, I'm in the same tab, sir, but the link is not visible in my portal, sir.
Okay, sir. Then I'll.
Actually, the time is, sir. Actually,
sir?
the time is 6:25 alone. By 6:30
Yeah.
alone,
Okay,
that will be visible.
By
The link
6:30,
will be
please
visible.
check, sir. Please check, sir, by 6:30. Otherwise,
Okay.
I'll give the link.
Okay, sir. Okay. Thank you, sir.
Yeah. So please log into your Atal portal, sir, and check whether any participant have got the assessment link.
Can we leave the meeting now?
Yes, sir. I
So
got the
test is
assessment
not
link.
assigned in the assessment link.
So kindly refresh it once again. So kindly refresh your Atal F portal.
Okay.
And a small
No, sir.
instruction.
No,
Small,
sir, I didn't get it.
Sir?
No, sir, I didn't get the link, sir. Probably
Okay,
we'll
don't
get the
worry,
link
sir.
only
Don't worry. By
yes,
6:30,
yes, sir.
by
Yes, sir.
6:30, I mean, please check, sir, once again. Otherwise, I will provide you the link. Sir, one more request is that by 7:30, kindly join, sir, because we have to take the group photo. So
Please provide the link for test.
pardon
In
me,
the
sir.
assessment test is not visible. Please provide the link on the group.
Yeah, please check by 6:30, madam.
Okay,
In
sir.
case you don't find, please ping in the group.
Okay, sir.
And kindly another announcement, by 7:30, all of you join back, as we have to take a group photo. So this has a feature called taking a group photo. So we will together mode, you can check this. So like this, when you turn your camera on, so you'll be positioned at some place, some seat.
Hello.
Yes, sir. Yes, madam.
Sir, is it accessible on mobile device?
Yes, sir. Yes, madam. It is accessible.
Okay.
Yes,
And
ma'am.
Like
link is
group photo. Pardon me.
7. Hello.
Yeah, madam.
Is the link open up to 7:30 only?
Yeah, it is a time-bound test, madam.
Okay. Thank you.
So please complete by 7:30 or so, and we'll join back for a group photo like this. When everyone of you will turn on your video, then people will appear in a gallery, big gallery like this. So it is essential for us to take a group.
Sure, sir.
Okay, sir. So I wish you all the best. Write your test.
Thank you, sir.
Thank you, sir.
Okay, okay. Thank you. So if anyone is having some problem, please ask me for the link.
Sir, if there is any problem, we will update in the WhatsApp.
Sir, if there is any?
If there will be any problem during the assessment test, then I will definitely update you in the WhatsApp group.
Yes, sir. Yes, sir. Definitely, sir.
Sir, I'm not able to even give the feedback. It's not showing the submit feedback button, though I have filled all the options.
Okay.
Sir, I do have an issue. Like
Okay.
if I try to submit the feedback form, it says that your attendance is not marked.
Okay, then I think I have to update the attendance. I'll do it by tomorrow evening, and probably check back once your attendance is given by me. Then you can give a feedback.
Yeah, the attendance is not updated. That's why it's not permitting to submit the feedback.
Okay, madam. No issue, no issue. But I'll be giving you the messages from time to time in our WhatsApp group.
Okay, sir. So can we leave the meeting now?
Yeah, madam. You can write your test. You can, I mean, you can be online if possible. Otherwise, so you can quit here, write your test, come back at 7:30. I am waiting for you.
Okay. Thank you.
I'm waiting for you all. Thank you, madam.
You.